Hi, my name is Alex Fleischman, and welcome to the video overview for the thermocouple demonstration. Alright, so what's going on in this demonstration? Thermal conductivity is a constant for a specific material that identifies how quickly heat can pass through it. This is similar to electrical conductivity, which is how easily electricity can pass through a specific material. Some students may ask for some examples, so you could state that the thermal conductivity values is 385 for copper and 205 for aluminum, which are both measured in watts per meter Kelvin. Alright, let's go over this. This demonstration will introduce students to how a small voltage can be produced from two different metals being in contact due to thermal conductivity. You can show the students that a voltage is produced by hooking up a galvanometer to both metals, and then heat both metals, and you could see an increase in voltage. Once students have seen the increase in voltage, you can conclude that the voltage produced is a result of the different thermal conductivities of the metals, showing that thermal energy can be converted to electrical energy. Before you even begin heating the thermocouple, ask students to connect two copper wires to the galvanometer. What voltage did the galvanometer read? Well, it should read 0, because there is no source of energy such that a battery connected to either the thermocouple itself or the galvanometer. Some students may ask, what would happen if we switch the copper wires? Well, the galvanometer should still read 0 volts due to no energy source. Now, light a candle and place it underneath the thermocouple. What does the galvanometer read? Well, it should read a voltage greater than 0 volts. This is because we now have an energy source. Well, what is the energy source? Well, the candle is releasing thermal energy, and the galvanometer detects the electrical energy, or more specifically, the voltage through the thermocouple. What would happen if we remove the candle? After 30 seconds, it should still remain about the same, but after a longer time, such as 2 minutes, it should significantly decrease. Some students may ask, will the galvanometer ever reach 0 volts again? Well, it will eventually return to the reading of 0 volts, so long as the thermocouple is not reheated by the candle. Once you have concluded the demonstration, ask the students to make a couple generalizations regarding the thermocouple and thermal energies. They should conclude that a thermocouple contains two different materials with different thermal conductivities. Students should also come up with the generalization that when a thermocouple is heated by a heat source, such as a candle, thermal energy can pass through the two different metals. In addition, the thermal energy can then be transferred through the metals into electrical energy, which then be detected by the galvanometer.